Hello everyone, welcome to my video. I'm Aynura Nuriyeva and today I am going to explain you the chain rule. Before we start, I would like to mention that we already know how to find the derivatives of different functions. But today we are going to learn how to find the derivative of composite functions. By composite functions, let's remember what is the composite functions. As you know, composite functions, we show them as this, or f of g of x. This is the composite function. We can show it like this or like this, doesn't matter. So if we want to find the derivative of this composite function, before finding it, we should check some points. Which are them? First of all, if we write, we can call g of x as u. We can write that g of x is u. We can show it as u. If g, the function g, is differentiable at x, if g is differentiable at x, and the function of f is differentiable at u, at g of x, it doesn't matter. F is differentiable at u, or we can write it like g of x, yes, at u. So we say that the composite function f of g of x is differentiable at x. Composite function f of g of x is differentiable at x. After checking this rule, if this is true, if the derivative of g at x exists and the derivative of f at u exists, so it means that the derivative of the composite function f of g of x exists at x. So after checking this rule, how can we find the derivative of this composite function? For finding the derivative of this composite function, we can check a rule. Yes. How can we find the derivative of this composite function? If we derivative of this is derivative of f of g of x and derivative of g of x. We find it like that. Okay. If we show g of x again as u, and if g of x is u, f of g of x is gonna be f of u. We can show f of u as y. If we show f of u as y, dy over dx is dy over du multiplied by du over dx. So they are similar. We can use both of them for finding derivative, but this makes this rule more obvious that we can see here. How can we find the derivative of composite function easily? And I would like to explain it in one example. Let me write. So let's write one example. For example, y is ln square x minus ln x. So how can we find the derivative of this function? First of all, as we say, this is the difference of two functions. For finding the derivative of y, first we need to find both derivatives. Okay, both derivatives. We will find this and we will find this derivative of them. Then we'll find their derivatives difference. Okay? First of all, let's find the derivative of this function. Derivative of, first of all, derivative of y, derivative of this function is what? Derivative of ln square x. We can, as you should see, we know how to find the square functions, x square or v square, u square, but this is the composite function as we see. This is the square of ln x. So we can show ln x as u. Let's show ln x as u. This is, as we see, u square. Yes, this is u square. And also, we can show also ln x as u here because we know how to find the derivative of ln x, but we don't ln x, ln u, ln v. It doesn't matter. Variable doesn't matter. But we don't know how to find the derivative of ln x. But after learning the chain rule, we can find it. We write ln x as u minus ln u. Now, we find its derivative. Okay? Its derivative, we can find the derivatives one by one, and we can find its difference. Derivative of u square is 2u multiplied by derivative of u, du over dx, because u is also a function of x. Du over dx minus, we know how to find the derivative of ln u. Derivative of ln u is 1 over u multiplied by, again, u is a function of x, so we write it like L du dx. Yes? So u is ln x, 2 ln x multiplied by the derivative of u, du dx, is 1 over x. We write it like 1 over x minus 1 over u is ln x multiplied by, again, du dx, 1 over x. So we find that, and this is also, we can show it like dy over dx. Yes, this is the respect derivative of y in respect to x. Dy over dx, or the derivative of y, is 2 ln x over x minus 1 over x ln x. Again, for finding the derivative of y, we found both derivatives one by one. Ln square, derivative of ln square x, and derivative of ln x. Derivative of ln square x, we showed in both functions ln x as u. Derivative of u square minus ln u. We find both derivatives one by one. We find the derivatives one by one. Derivative of u square is 2u, and the function u is the function of x. For this reason, we write du dx multiplied by du dx minus 1 derivative of ln u, 1 over u multiplied by, again, u is the function of ln, the function of x. For this reason, we write the derivative of u with respect to x, 2 ln x, u is ln x, and derivative of u, derivative of ln x is du over dx, 1 over x. We write it 2 ln x, 1 over x minus 1 over ln x multiplied by 1 over x. So we find again dy dx, the derivative of y with respect to x, 2 ln x over x minus 1 over x ln x. So thanks to this example, we can easily understand how to apply the chain rule. So that's it for today. I hope this video is gonna be helpful for you. That's all. Thanks for your attention.